This is part 3 of our lesson on solving exponential equations. We just finished looking at how to solve equations by writing things as powers of the same base. Our second 2 examples are going to be how do I solve an exponential equation using logarithms. So my example here is 2 times 7 to the power of 3x minus 5 times 7 to the power of 2x minus 200 times 7 to the power of x plus 500 equals 0. So when I'm looking at this question, I notice that I have 3 powers. I have 7 to the power of 3x, 7 to the power of 2x, and 7 to the power of just x. So I know this is exponential, and I know I'm going to have to do something. I can't really work on writing them as powers of the same base because they already have the same base. They already have a base of 7. Now, I am going to just rewrite these a little bit. I'm going to say this is 2 times 7 to the power of x to the power of 3, right? We multiply exponents when we have an exponent on a bracket. So if I have things multiplied together, I can break it up into an exponent with a bracket. The 7 to the power of 2x, I can write as 7 to the power of x to the power of 2. And then this is minus 200 times 7 to the power of x plus 500 equals 0. So I now notice when I look at this question that I have 7 to the power of x, 7 to the power of x, 7 to the power of x. So I would probably, at this point, use a strategy that we like to use called variable replacement. So I'm going to take out the 7 to the power of x, put in some other variable other than x, and then see where I can go from here. So I am going to let a equals 7 to the power of x, and then I'm just going to take those out. So I'm going to get 2a to the power of 3 minus 5a to the power of 2 minus 200a plus 500 equals 0. So I now have a polynomial equation, and the polynomial is equal to 0, which means I'm able to solve. So anytime we're trying to solve, we would like it to equal 0 if we're either going to have to factor or use quadratic formula. Now this has 4 terms, which means I am not allowed to use quadratic formula. That's not a possibility, but I could maybe factor it. So I do have some options in terms of factoring. You know what? I just figured out where the button is to make this brighter. That's very exciting. I do notice it's flickering a little, and I am sorry about that. So from here, I do have 4 terms. Do they have a common factor? No. Could I factor by grouping? I'm really hoping the answer is yes, because otherwise we have to do polynomial factoring using the factor theorem, and I really don't want to do that. So I notice the first pair has an a squared in common. If I took out the a squared, I would get 2a minus 5. Could I get a 2a minus 5 out of this bracket? Well, it looks promising because I have a 200 and a 500, so I think we might just be in luck. So I'm going to group together my first 2 and my last 2. Out of the first 2, I can take out a squared, and I get 2a minus 5. And then out of the second 2, they both divide by 100, and I'm going to do negative 100 because the first term out of those is a negative. And I'm going to get 2a minus 5, which means factoring by grouping was a success. So I have 2a take away 5, and then a squared minus 100. And that equals 0. All right, so we have factored. We factored by grouping. Can I factor either of those brackets further? Well, 2a minus 5, unfortunately, does not factor any further. But a squared minus 100 has 2 terms. They're being subtracted, and they are perfect squares, which makes them a difference of squares. So the first bracket is going to stay as 2a take away 5. But a squared minus 100, we do the square root of a squared to get a. The square root of 100 is 10. So we're going to have a plus 10 in one bracket and a minus 10 in the other bracket. And that still equals 0. So at this point, my equation is factored. I am multiplying three things together, and we are getting an answer of 0. So I can take each one of these and individually figure out what would make them 0, because if any single one of these is 0, 0 times anything is automatically 0. So 2a minus 5, I want to know what makes that equal 0. I have a plus 10, and I would like to know what makes that equal 0. And I have a minus 10, and I would like to know what makes that equal 0. So we're going to do a little rearranging. I'm going to add 5 to get 2a equals 5, and then divide by 2 to get a equals 5 over 2. For the a plus 10, I'm going to subtract 10 from both sides to get a equals negative 10. And then on a minus 10 equals 0, I'm going to add 10 to both sides to get a equals 10. Now, I feel at this point that I am finished, but the original question did not have a's. The original question had x's. So I need to reintroduce that 7 to the power of x. So I'm going to take out the a and put back in 7 to the power of x. So 7 to the power of x equals 5 over 2. 7 to the power of x equals negative 10. And 7 to the power of x equals positive 10. Okay, so how do I solve from here? How do I find what x is? So on the previous examples, we tried to write them as powers of the same base. But 5 over 2 is not a nice power of 7. Neither is 10. 10 is not a nice power of 7, and neither is negative 10. So there is another strategy, and that is using logs. So the inverse of a power with a certain base is to do a log with that base. So if I have 7 to the power of x equals 5 over 2, I'm going to take that 7 to the other side by doing the inverse, which is a log base 7 of 5 over 2. Okay, for this one here, 7 to the x equals negative 10. That's going to give me x equals log base 7 of negative 10. We need to talk about that answer in a second. And then for this one, I'm going to take this power of 7 to the other side by doing log base 7 of 10. All right, log base 7 of 5 over 2 is going to be a decimal. It didn't mention in the question anything about rounding, so I think we're going to leave our answer as an exact value, which this is. So I'm going to leave my final answer as log base 7 of 5 over 2. Now, if I did want to work that out as a decimal, I would have to do some change of base. So my calculator does not do log base 7. It can only do log, which is log base 10, and ln, which is log base e. So you can use either of them. You can either do log or you can do ln. I like ln. So I'm going to do ln of 5 over 2 divided by ln of 7. So when we do change of base, we do ln of the argument divided by ln of the old base, or log of the argument divided by log of the old base. And then if I wanted to calculate that and it didn't ask me to, I would do 5 divided by 2 in a bracket, and then ln divided by 7 ln. Now, if you have a calculator where you see what you type in on the screen, you would probably hit ln first, and I get approximately 0.47. So 5 over 2 is definitely less than 7, but bigger than 1. So around that number seems to make sense to me. What about log base 7 of negative 10? There is something about that that has made my math sense just kind of go off here. So logs, you cannot take the log of negative numbers or zeros. So this one here, because this is a negative number, but the base is a positive number, actually has no solution. So this part here is no solution. And then the last one, log base 7 of 10, That's perfectly fine. It's a nice number. It's positive. Once again, it's going to be a decimal. If I wanted to work it out, I would have to do ln of 10 divided by ln of 7 or log of 10 divided by log of 7. So I ended up with two solutions. I have log base 7 of 5 over 2, and I have log base 7 of 10. You can join me in the next video for our last example in this lesson.